Welcome to the Defect Extension demo. My name is Jen, and I've had the pleasure to work on this amazing project with some of our technical artists as well as some of the people from our replicator team. So, by now, you are probably watching this video because you have downloaded and put this extension inside of code or create, and you're like, I want to get started using this. So let's go ahead and let's get it working. So I already have mine installed, so I'm just going to go ahead, I'll enable it. We have this UI that will pop up with a couple different categories on here. So what we're going to do is we're actually going to go through each one of these from top to bottom in order on how to use this extension. So the first thing is that I'm going to go ahead and I'm going to create a disk. Now for your use case, you might be using some type of CAD file or model file. That's totally fine as well. It'll still work the exact same way. So for mine, I have my disk. So I want to make sure that it is selected in my stage. I'm going to go head over to the defects sample extension UI and click on copy inside of our object params for our target param. What this is going to do is it's going to say, this is what I want my defects to apply to. Now that we've selected it and copied it, we're going to go ahead and hit apply. What this will do is it'll bring in our proxy with our material, as well as go in and create some of these prim vars on our applied model. In my case, since it's my disk, I selected it, head down into the stage. Inside the properties panel, inside the raw USD, you can see that we've created a couple of different prim vars, such as prim vars d forward vector, position, right vector, scale. All this stuff is actually being driven by our pseudo decal material. And if you want to take a look and see where those are taking place, you can go ahead and right click on it and open up the MDL material graph. Now that we have it in the scene, as you can see, we have our proxy, but we can't really see our disk anymore. That is because it's kind of using this really dark material. So I'm going to go ahead and turn all my lights on to default just so we can see it better. So now that we've applied everything, let's head over to our defect parameters. So the first thing is our defect semantics. So this is the label that will actually get applied. So when all of our information gets spit out for when we're trying to do model training, this is what we're going to be looking for. So I'm just going to call it scratch. Next is our defect texture. So essentially we are showing it, hey, these are all the defect textures I want to bring in. So these are going to be your normal maps of your defect in a PNG format. So I have about 100 different scratch images here in this folder. So I'm going to go ahead, I'm going to select this folder. From then, we have a couple other ones, such as the dimension width and the length with a min and maximum value. These values are then going to get placed into Replicator's logic for its distributions. So it's going to pick any number between our minimum and our maximum value as it kind of starts creating our synthetic data. So for width, if you imagine a scratch is going to be kind of thin, so I'm going to do about 0.5 to 1 for the width. As for the length, well, scratches can be long, but they can also be short too, so maybe we want to do somewhere between 0.6 to 2. Now that we've defined that, the next section is our region. So if you only want your defects to appear on a specific region of your model, or if you don't want the region and you just want it to scatter all over it, you can do that as well. Either one, if you want to, feel free. I'm going to, in this case, I'm going to say I would like my region to be right around here. So now when we're running our synthetic data, our defect will only appear within this area. Again, if you don't want to define an area and you want it to go along the entirety of this disk, then you don't need to define any kind of region. Rotation, this is about the same thing as our dimensions width and our dimensions length. I'm going to say from 0 to 360. And that's it for our defects parameters. So lastly is our replicator parameters. So the first one is our output directory. This is the directory in which this will end up getting outputted at. If you don't specify one, it's just going to go to basically your default location, which is going to be under whatever drive, your users, your username, and then it'll be a folder called omni.replicate_out. Again, if you don't want it to go there, you can specify a folder location. Next is our render subframe count. This is super important if you are trying to create your synthetic data in real time, because what this will allow is it'll allow for the rendering of your defect to appear before it actually moves on to the next frame. So sometimes you want to wait for a specific amount of frames just to make sure that everything renders in properly first before going on to the next one. I found 50 to be a good number for my computer, and I'm running two A6000s with an NVLink. Once we have all of that, we can go ahead and we can create our replicator layer. What this will do is it'll create our Omni graph. So replicator basically creates this Omni graph that drives all of our synthetic data generation. So now that we've done that, I'm going to go ahead, I'm going to take a preview just to see what this looks like on our disk. So I'm going to zoom in a little bit here. Maybe I want to switch to a top view just so we can get a better view of what's going on. So as you can see, our scratch has shown up over here. So if I'm going to hit preview again, and let's just make sure that our data looks good. These scratches are coming in real nice. I think I want to go a little bit bigger. So we can actually do that real easily. So back in our defects parameters, I'm going to make this going from maybe like 0.8 to 2. And now that we've made a change here, we can go ahead and we can just recreate our replicator graph. So we'll take in all of our new information and apply it. So now if I hit preview again, it'll have all of that new information. So I'm kind of liking what this looks like so far. It's a little bit hard to see with that on. As you can see, it's still in our defined region. Looking good. Okay, now that we have that, I'm going to go ahead and I'm going to set this for 50 frames. So I want 50 different images and data of this scratch within this disk space. Okay, so now we're going to go ahead, we're going to hit run. So I'm going to hit run here. And as you can see, it's going to basically wait 50 subframes before moving on to the next one. And as you can see, it's moving around our disk here, creating all of that images. Awesome. So it looks like it's finished. So now that it's finished, let's take a look and see what our data looks like. So over here, we can actually see all the images that spit out here. So let's take a look. Let's take a look. So as you can see, we can see our scratch over here. Might not be a really good quality, and that might just be some little tweaks we would need to make with the camera. Seems like, ooh, that's a really tiny scratch over there. Let's go to the next one. Oh, we can see another one over here. You can see one over here. So we have all these different images. This one looks really nice. We also have one over here. Looks really nice as well. And then, as you can also see, we have created all of our JSON and our MPY files. And that's pretty much it.